Okay, here we go. I gotta say the exact same things again. We're working on the Tic Tac Toe, and now I have a client and a server. The client, the client's over on this side. It puts the Slytherin crests in, and the server puts in the Gryffindor crests, and they don't seem to communicate with each other. I mean, that technically they do. You can see, like, if I click over here, 0, 0, you can see the message gets sent across. Right there, it says 0, 0. So definitely my client listens and knows that the server clicked on 0, 0, but it doesn't seem to do anything with that information. Similarly, I could click over here with my client, and we can see that I clicked on 2, 0. It sent that across the server, but it didn't do anything with it. So what we're going to do right now is figure out how do we, like those messages are being sent, what do we do with those messages? And in order to do this, before you can attempt to do this programming, you're going to have to build the client as well. I think we've just been mostly working on the server, so you'll have to build both sketches, although they're almost exact mirror images of each other. Like if I just like quickly show you like what this looks like, I don't know, it looks pretty much exactly the same. We're loading the same images. Oh, I guess it's a little bit small. I'll have to up this up. Here's this while loop over here to draw the grid. It's the exact same while loop right over here to draw the grid. Like they're pretty much mirror images of each other. The only thing that changes is the client server stuff. So I have different ways of reading and sending messages. But that's just the exact same story as the chat program. So yeah, I'll up the size so that people in the room can see what's going on. And we'll talk about how do we receive the messages. Oh, actually, one last thing. In each sketch, in both folders, you have to put your images for drawing the whatever your X and O symbols are going to be. So don't forget to put those images in both the server folder and in the client folder, or it won't work. It's easy to forget that they're two separate programs, but you have to do it. Okay, so anyways, we'll go to taking a look at how do we receive the message and do something with it. I guess I'll do it. Actually, I'll do it in the server because that's the one we've been mostly working with. So here's my server, and this is where I'm reading in incoming message. So this code is identical so far to what we've been doing with the chat program. So basically, that coordinate, the row and column has come in and been stored in the incoming string. So what I need to do is I have to take apart that string and unpackage the numbers that come out of it. And the incoming string is always of this format. So it's going to look like a number. It's going to be the row, and then a comma, and then a number that's going to be the column. So I just got to pull those things out of the string. So how do you do that? That's the way you can do it. The answer, well, there's two answers, and I don't know which one is harder. So I'll probably just go with one and see what people think, and I can show you the other one if you want. But we're going to use something called substring. So substring basically allows us to take apart a string and get just a piece of it. So for example, here's a typical kind of row column information I send across. Maybe I'm sending it across a row and column that looks like this, 2, 1. I want to get row 2 and column 1. So how is it that I would access these different parts of the string? So just like an array, I'm trying to click across. I can't do it easily on a Mac. I don't know why it's so hard on a Mac. Here we go. Trying to get there. You can do it. So each one of these characters is numbered in a string. They have an index. Just like your grid has an index for row and index for column, a string also has a similar sort of index and column number. Can anybody guess what is the index number for the first character of a string? 0. You got it. It always starts counting from 0. And pretty much it's just up by 1 each time. So no, it's just as bad as all the other things we've done in the past. So this one's going to be number 0. This one's going to be number 1. This will be number 2. And honestly, that's it. That's all we got for tic-tac-toe. It's never going to be more than that information because all we need to know is a row, which is between 0 and 2, and a column is 0 and 2. So it's basically going to be those three things. So how is it that I access the first one? So here's what I'll show you how to do it. First of all, I'm going to make a string called row, and I can piece off the first number of this string by taking the string. It's called incoming, and do the substring function from it, like this. And substring requires you to give it 2 parameters, although I guess that's not entirely true. You can give it 1 parameter for a different operation, but we're going to give it 2 parameters. You're going to give it, first of all, the start of the substring, which for us will be 0, and the end, but not including index number for how far we want to go. So if I want the first character, I'm going to type in 0, 1, which means it'll get the first character, or get all the characters from 0 up to but not including 1. That's just how substring works. This one is inclusive, this one is exclusive. So that will give me the first letter. If I wanted to get the column, what do you think that would look like? Oh, it doesn't seem to like that. Duplicate variable. Oh, I already have a row. I guess I can't use that. So I'll do a row string, I guess. I don't know. I already have a row variable here, so I'll just make a row string and column string. If I wanted to get the last letter, or character, whatever it is, it's obviously a number. What would I put in here? What would be the first number? It's or just waiting to get. It just wants some numbers in here. So, oh, sorry, what was the answer, Serena? Dot length. Oh yeah. So you're right. So if we didn't know the length of the string, if it was going to be a random length or arbitrary length, we could use dot length to get the last number. It turns out for this one we don't need that though, because it's always length 3. Everything we send across is always length 3. It's always number, comma, number. So we always know the how long it is. It's always going to be the same length. So of a 3-character long string, what do I need to put in here to sort of select the last number? We won't have to use dot length because we know the length. It's always going to be 3. 2, 3. You got it. You got it. This selects character 2 all the way up to, but not including 3. There is no character 3, but that's okay because that's the end of the string and it doesn't include it. And I mean, we could print these to just determine if we succeeded or not, but I'm pretty sure that's going to work out nicely for us. And then, it would be nice if that was the end of the story. Like, then you could just kind of remember how substring works, and that's it. However, if you tried to stick these in the grid, if I did grid, row string, column string, it's not going to work because those aren't numbers. Those are strings. It's a string that contains a number that, or a character that represents a number, but it is not a number itself. Isn't that annoying? So we're going to have to convert it from a string to a number. And the way to do that, I'm going to just make an int that's going to be, I guess I'm going to call it R. I think that's okay. And then I'd like to do this operation, but it doesn't let us just copy it over like this. It would be nice if you could just make an int, make it equal to a string, and just like magically transformed it. Unfortunately, that doesn't work. And I don't think the int function, does the int function work for it? Let's see. Oh, I think it does. Nice. So actually, we can just use the int function. In pure Java, we'd have to do something else. But in processing, we have the int function. So we can just stick a string into an int function, and it's going to spit out the number that corresponds to that string. And we'll stick it into this R variable. And I'll do the same thing for column. I'll make a C. So it'll be converting column string. So now R and C are the actual numbers, so then I can stick those into the grid. So I can say grid R, C equals, and then what do we make it equal to? Well, this time it's going to be 2, because the server, when I make moves, is going to be represented by 1s. Incoming moves, I'll represent with 2s, so I'll have a different symbol. So that's a lot of work, hey? So first of all, you have to break up the string into the correct components. And then you have to convert those into numbers, and then the numbers can be used to access the correct spot on the grid. And there we go. And somebody's clapping out there, I'm just going to assume. They're excited about the network programming that we've just done. So that's good. Does it work is a whole other question, though. So let's run it and find out. I'm going to run the server. And then, I guess I better get the client. Where are you at? Client there. It's right over here. I'll run the client. Well, it was running, but that's fine. Okay, so I've programmed the server now to listen for client messages. So I'm going to click on the client and see if it does it in the server. Okay, so here we go. Woo! Yes, it works. I can click here, and it sends the message across and puts it in the right place. If I click over here, doesn't work yet. But it's the exact same process to get it to work in the client. You're going to receive the same format of a message. So you got to just do the same kind of substring stuff to break the message into the different parts for row and column. And you're going to, of course, turn those into ints and modify the grid. So with that knowledge, hopefully you'll be able to kind of make this happen. There's a little bit more work to do, though. And that's sort of the network part of it and dealing with the strings and the data. But I'm just going to quickly mention, to finish this project off, what is left to do. So after you've done all the networking programming and you click on one side, it sends it over to the other side. The last two things to do are, first of all, you can cheat really hard in this game. Watch this. Oh, did you go here? No, you didn't. Boop. You can just overwrite other people's moves. That's how my kids play tic-tac-toe. They no, you didn't make that move. I made that move. Oh, okay, that's not going to make for fair gameplay. And this person could just overwrite the other person's moves too. That's not good. We should probably prevent them from making moves in squares where the grid is not 0. They should only be able to play in squares that have a corresponding grid value of 0. So that's going to be some kind of if statement that you're going to make your mouse pressed function a little bit more complicated. So when you make a move, you can choose to deny them from making the move. And you don't have to make any fancy thing. If you want to print some invalid move on the screen or whatever, that's fine. But you're not required to. Just don't let them make that move. The second thing is, here I am, I'm Slytherin. I'm just going to keep making moves. I'm going to be yeah, there we go. Here I win, here I win, here I win. I don't take turns anymore. As there's no turn-based mechanic. When if the Slytherin is obviously going to be the faster player, right? They're ready to win this at all costs. They can get in there just spam, click, 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 and win. It's not turn-based. Tic-tac-toe is not a real-time game. Although, actually, now that I'm thinking of it, I think that might make a fun game. A real-time tic-tac-toe game where it's just who can click the fastest. There's some potential there for a goofy game. Maybe it would have to be a 10 by 10 grid to make it fun. But I'm going to ask you guys to make it a turn-based game. So you can just decide who goes first. I think traditionally whatever player you consider the X is the one that goes first. When they make a move, it stops being their turn, and then the other side gets to take their turn. So you need to keep track of some kind of variable that represents whether or not it's your turn. I would recommend a Boolean variable. Call it my turn, and that can either be true or false. The client will start off as, say, false, and the server will start off as true. When you make a move, you need to flip those variables. So either program will need to sort of reverse the true and false values. And you should only be able to make moves when it is your turn. So that's sort of the last two parts of this project. So if you get this network stuff working, awesome. Then add in the ability to not overwrite moves. So if you click on try to make a move, it won't work if it's already a slot that's been taken. And then make it turn-based. So once you've taken your turn, you can't do it again until your opponent has taken their turn. And there you go. That's our program. If you finish that early, I'll tell you what we're working on next week. And maybe we'll have a bit more time to finish this off. We'll see. I don't know how long this will take. It might take you all day, and maybe most people will not be done by the end of today. So we might work on it next class as well. But if you do finish, the next project is going to be checkers. So tic-tac-toe and checkers aren't really that far apart. It's an 8 by 8 grid instead of a 3 by 3 grid. And there's certain pieces that you may have to move. So we're going to be making moves in checkers. We'll have a similar sort of turn-based framework. And in checkers, it's a little more complicated than just clicking on things. You have to make a move. So you have to select a checker and then move it to another square. So that's a lot more information you have to send. It's not just a single row column. It's 2 row columns. It's the checker you clicked on and the place it's going to move. So there's a lot more data to send, or at least double the amount of data to send across the network. People are clapping again. I'm sure they loved it very much. So, folks, I'm going to stop the video now, and we'll come around and answer your questions.